Hello guys, today I'll be showing you my IoT project. As you have seen from the title, we'll be building an application which is similar to the UPI Payment Sound Box or any other sound box that you may have seen. So I'll just tell you what the features are. Firstly, obviously voice-based alerts for the received payment amount. Secondly, we'll be using a scalable database like MongoDB to store the transaction information such as the sender ID and the received payment amount. And thirdly, we'll also auto-generate invoices and store them in Amazon's S3 bucket. So let's first go over the demo of the application. So I'll cut right now. So I'll tell you the components now that we require to build this DIY UPI payment box. So firstly, we'll require the MP3-TF-16 module or the DF player. It is used to play the audio files for the voice alerts. We'll also need an SD card and a speaker because we have to connect that to the MP3. We will play some pre-recorded audio files. I'll tell you how to create those, etc. And the speaker should be of around 2 to 4 ohms. That will work with the our board. And next, for sending the SMS to the customer of the invoice, we will need a SIM module. I am using SIM800L module. You can use any other GSM module if you have any. And third, we'll require an LCD to display the payment amount, and we'll need a keypad so that we can input the user's phone number. And mainly we'll be using ESP32 as the microcontroller here, and we'll use Arduino IDE to program it. And you'll also need an AWS account and a database connection where you'll store the information. So now I'll show you the connection diagram and we'll build side by side together. Okay, so I have already connected the MP3 module and the SIM module, and I've also inserted my SIM card. So I will tell you the connection, how to do this, and I have also posted the connection diagram on my GitHub repository, so you can have a look from there as well. So firstly, I will connect the LCD module. So as you know, we are using I2C, so it has 4 connections: ground, VCC, SDA, and SLC. So this one is ground, so I'm just giving it to a negative terminal here. And then we have VCC. I'm connecting it to here, this one. Then this blue wire is for the SDA, so you need to connect this to the port number 21, port 21 here. So I'm connecting into port 21. And the next one is the SLC. You need to connect this to 22, and I'm connecting the ground as well. Okay, so this is for LCD connection. Then let's move over to the MP3 module connection. The first one is the power, so I will use this first one here is the power. I've connected it here. Okay, the next one is the RX, so you need to connect it to the port number D2. So the immediate next to the yellow wire is the RX, which you need to connect to the D2. So I'm connecting it to D2. Okay, the next one is the TX, so you need to connect it to D4. I have defined in the code them as the RX and TX, so that is why I am doing this connection. Okay, and then for the speaker connection, you have to leave one pin, and after that you have to connect this two for the speaker. So I will just connect them for as a speaker. Yes, I've connected them, and the next two pins need to be grounded. So I'm using this one to ground them. The next two pins need to be grounded. Okay, now we have to connect the SIM module. So as you're seeing this helical spring here, that is for the network connection, and the immediate next to that is the power VCC. So we'll have to connect it to the VCC. I'll just get a wire. So this one right here, just after the spring, connect to the VCC. Then the next pin is the reset, which we are not going to use, so we have to leave one. And again we have the RX and TX. So we are connecting the first one to number 17, which is the TX in our case. So connected to, you just connected to the TX2 here, TX2, which is 17 number pin, and you have to use one more. And yes, this one you need to connect to RX2. So TX2 and RX2. And the last connection for the SIM module, we need to ground this. So I'm going to ground this. You can do this here as well with the ground connection, and use this two pins, V in and ground pin, and you have to connect the V into the plus sign and the ground to the negative sign. I'll do that later. First I'll do the keypad connection. It would be better if you follow the connection diagram. I've defined it clearly which pin to connect, so I'll just fast forward this process. Everything as per this diagram. I have shared this already in my GitHub repository. You can have a look, and it is easy to connect them. One more thing, we'll not be able to use the serial monitor with this project because we are utilizing both of the serial ports of the ESP32. One is for the MP3 and another is for the SIM module. So now you just need to power this up with the laptop, and then you have to flash the code, and I will be explaining the code in the next part. So now I'll tell you what the code I have used for this application. Firstly, you will require these libraries. Now Arduino JSON is used for passing the JSON response from the API. Liquid Crystal I2C is used for the LCD, DF Robot, DF Player Mini, which is used for the MP3 module. So you need to have these libraries. If you do not have, you can install it via manage libraries here. And then you need to initialize the DF Player Robot and the Liquid Crystal I2C, which is the LCD. And then you also need to enter your Wi-Fi or the hotspot's name and the password. We'll require this because since we are using a server, Node.js server, so to communicate this application with the server, we'll require them to be both on the same network. That's why we are connecting it with Wi-Fi. Now I'll tell about these functions later. First, I'll explain the flow of the uh, application. So if you go to the setup here, so whenever the ESP board is booted, firstly we'll initialize the serial ports, and then we'll connect to the DF player. So during the connection, there will be an audio notification which will be played, something like the UPI payment box is active now, and along with that we'll connect with the Wi-Fi, and then we'll we are mostly sending this 280 commands. So what these 80 commands do is that they'll put the sim into the text mode, like we'll be receiving text. So for this, these 280 commands are necessary, and for the second one means that it will send the received SMS to the serial port 1200. It will immediately send to the serial port the received SMS. After this, the loop part will begin. Now in this loop part, we are continuously checking for any SMS that we have received from our bank's SMS service. So we are checking that, and once we have received an SMS which is of this kind, this is a sample message. So there will be obviously the payment amount received and the sender ID. So we are extracting this information, and whenever there is a message which contains both these details, then we will uh, go into this inner loop, and we'll firstly play the voice message. of the alert, and then we'll call the API, which will store it in the database and create an invoice for us. And after that, we'll request the user to enter his or her phone number so that we can send an SMS with the invoice. So this code is for that. And now I'll tell you the logic of how we are checking the SMS, sending the SMS, and playing the voice notifications. Now we'll go over each of the functions which I have created. Firstly, this check SMS function. So what are we doing here basically is that whenever we receive a message via the SIM module, we receive this plus CMT kind of code which indicates that there is a message present. So we are reading the SMS continuously while serial to dot available, and whenever we get a line which starts from this, which means that there is some message which has come. So we take the entire string, the message string, and send it to this parse amount function. So now what this parse amount function is that it will, as I showed you the message earlier, it will extract the payment information and the sender ID. So that's what we are doing here. Currently, the vulnerability in this application is that we are relying on the our bank service to send us this SMS. Now, what if someone knows my phone number for which from where the notifications are received? So he or she can directly send me the SMS of the same format, and we can be fooled by that. To prevent this, if you have like a UPI business account, so Paytm or GPay will provide their APIs, and you can use them directly instead of this check SMS code. And from there, it will be like a lot easier, and you can implement the MQTT protocol as well. But since it's a DIY project, and we are assuming that you have set up the notifications for the payment amount in some other number which is not known to the public, so you can use this code in that places, in that scenarios. And this was the, like, we got the now payment information. We currently in this scenario, we have a payment message, and we have received the sender ID and the payment information. Now to play the audio, we are kind of implementing some logic which I'll explain to you. So for example, we have received 149 rupees. So we need to break this information into the number of like tens, ones, and hundreds. So for doing this, we have created 33 audio files which you need to pre-record. Now, out of these 33, first 29 are the things we require for the voice alerts. Now, if I play this one audio,
One,
you might have heard a one no, voice notification. And if I play, suppose this 20, so you'll hear 20.
20,
And if I play 21, it's 30. Then
30,
22, it's 40. So I
40,
think you are quite getting what we are trying to do here. So when I receive 149 rupees, so what we are doing through the code is that we are splitting this 149 into the number of ones, hundreds, and tens. So it will be broken into like 100, 40, and 9. So we will be playing audio files for each of those numbers. Like for one, we'll play this one. For
1,
100, we'll play this one. I think it's 27, 28. I mean, yeah, 28.
100,
It's 100. And then for 40, we will play this is one is 20, 30, 40. 22 will play
40,
40, and for 9 will play 9. So
9,
essentially what you have to pre-record the audio files is that 1 to 20 you have to record, and 20, 30, 40, 50, 60, 70, 80, 90, 100, 1000. So you need this many audio files. And what these four files etc are for, let's play the 30th one. This is for paise.
paise,
Like if we get suppose like 149.50, so it is for paise. And 31 is for rupees.
rupees,
So 149 rupees and 50 paise. What is 32?
received
Received
payment
payment
of
of. This is for received payment of. And 33 is,
UPI box
okay,
is
UPI box
powering
is
up.
powering up. So 32, first we'll play 32, which is you have received payment of, then 1, then we'll play 100, then we'll play 40, then we'll play 9, then we'll play rupees, then we'll suppose let's say 50, so we'll play 50, and then we'll play paise. So this is the the setup for the logic for this. And to implement this, I will show you the code firstly. Okay, yeah. So whenever we receive the payment amount, we are extracting the rupees and paise from here. So once we have the rupees and paise, we'll call this play amount audio function. Now, what this play amount audio function is that firstly it will play the you have received voice notification, and we have mapped these audio files via this function here. So like I told you this, right? This functions, these audio files. So I've numbered them here. So for 3, we will return the third audio file. For 11, we return the 11th audio file. For 100, we return the 28th audio file. So this will return us the it will return us the audio file number which we need to play. So firstly we'll play the you have received audio file message, then we'll keep it a gap of like 500 milliseconds here, and we'll use like half a second gap there to finish that amount of audio so that they are not simultaneously playing. Then we'll convert the 149 or the payment information into rupees, and we'll then do the similar for the paise if the paise is like it is present value, and then we'll play for the rupees in words. This will I'll explain you right now here. So firstly we'll convert number to words. So now how are we doing that? We are going to this function, and if the number is 0, we are returning 0. Then we are initializing a string, and we are finding the number of thousands. Like suppose if the main is of 3000, so it will find the number of thousand place. So we are converting that 1000, and if like it's lesser than 1000, we are calling numbers below 1000. And similarly for the numbers below 1000, we are doing the same. We are finding the hundreds number. Then for less than hundreds, we are finding this 1 2 3 till 20 or 90. So we have done this, and we are storing this information in the words array. And now what we are going to do here in this play words function, that will play the uh, each of the sentences that we have created, like 140 will play the will play the audio files for those. So this is how the music
Okay, so
logic is
now we have
implemented.
also figured out the audio, and the next step is interacting with the API for the database, saving the information to database and creating the invoice. So for this, we are using this fetch S3 invoice URL function, and in this function, we are sending a post request to our Node.js server, and we are sending the payment amount and the sender ID along with this. And the return in the return of the response, we are receiving the S3 location. So I will show you the Node.js code that which we are using. By the way, this all is available in my GitHub repository. I'll link it there, and you can try this project for your own there. Uh, okay, so I'll tell you the API which we are using. This is the schema for the payment, like amount, sender, and timestamp. It is basic. You can include or improve this further. And this is the API which we are using. So firstly, whenever we receive the like the API call, we'll check if the amount and sender ID both are present or not. And once they're present, we'll just save it into the MongoDB database. I've already set up MongoDB. You can watch some video or something else if you don't know how to do that, or you can ask me in the comments if you like. And then for the trial purposes, I'm saving it into my current local directory as well, just to know if it's actually saving it or not. And to create a PDF document, I'm using the PDF Kit library, which is a popular Node.js library for creating invoices or PDFs. So I've created a new document, and I've started a PDF stream, and I've created a logo along with here. And then when the creation is finished, I am sending it into the I'm basically making a call to S3, and I'm uploading this invoice there. And in the return, if you see here, I'm returning the data.location, which is the S3 URL of the uploaded PDF. And if I show you a sample invoice, open anywhere. Okay, I'll show you from here. Suppose this is the no, not this one. Yes. Yeah. Suppose this was the I did one payment here, INR1, and sender is this one. So this is the kind of invoice. You can improve this further. This is just for the uh, demo purposes. So after the we are sending the request to the API, we will store the invoice URL via the which is the response for the API. And after this, we are going to ask the user, like here, if the user presses the A key on the keypad, then we'll start inputting the number of the user. So this is the simple get phone number function which we are using. So it will store the 10-digit number, and immediately when the digit enters 10, like the number of digits are 10, we'll send the SMS. This is the SMS code. Send SMS. We are just using this 80 commands. It is quite simple, and we are just sending it. So this was the actual flow of the application. Okay, so as a confirmation for the demo, I'm like showing you where the invoices are getting stored. So I've logged into my AWS account, and I've navigated to the UPI IoT project bucket. And as you see here, all the invoices are being stored.
Along with this, I'll also show you the MongoDB the database which we are using to store the payments. So I've created a sample project here, and as you can see here, I've tested it quite a bit, 90 entries, something around like that. And this is the like schema as we set in the MongoDB server, Node.js server. So yes. So this is the end of the video. Thank you for watching till now. And if you have any queries regarding the connection diagram or how to, specifically write the code, and any problems in the code or any improvements if you want to suggest, you can contact me via the comment section. And here is the GitHub repository for this application. It has some details on how you can connect and what are the outputs for the application. I'll also add the link to the YouTube video here. And I've also added some additional code here. If you can see, if you are new to IoT like I am, you can use these individual codes to test the different components. Like if you want to just test the LCD and keypad, you can use this code. If you just want to check the Wi-Fi and SIM, you can use this uh, code. And if you want to see the Node.js code, so I've also entered it here. You can play around with the invoices, send me new templates as well. So this was it for the video. I hope you liked it. Thank you.